Hello and welcome to the session Daily Management and Pool in Finnair Technical Services. I'm Juha Tammi, General Manager for Lean Association of Finland. It's my pleasure to introduce you Jonna Kemppainen, Value Stream Manager, Component Maintenance, and Roni Kuhlström, Lean Coach. They come from Finnair Technical Services. All right, guys, the stage is yours.
Thank you.
Thank you, Juha, and welcome everyone to see our session. As Juha mentioned, we come from Finnair. We are the flag carrier of Finland, and we have a fleet around 80 aircraft at the moment. There is 5,200 of us here in Helsinki and all over the world, and we have been awarded with Skytrax's Best Northern Europe Airline Award in the past 13 years. So that's briefly about our company. And as Juha mentioned, we come from technical operations. Our operations are divided into 5 different categories. So we have an engineering department, planning and base maintenance operations, supply chain, aircraft maintenance, and then component maintenance services, where we are talking more today. Technical operations' main thing is to keep the Finnair fleet airworthy, safe, and fuel efficient, so that you can fly with our fleet. We have around 600 professionals here at Helsinki, and we have 7 in-house repair shops, also with line maintenance operations. And today we are focusing to one of those repair shops later on. But now I will have speech to Jonna.
Yes, thank you. I come from our component maintenance services, and I'm here to tell you about our journey in daily management and continuous improvement. I joined our team roughly 4 years ago to an environment where I discovered that we are scattered around the airport area, and actually, we had only one weekly management type meeting at that time, where we discussed about performance for previous week and then the future for the next week. I quite quickly discovered that this one production meeting didn't quite cover how we would track and keep track on our work through the week. Also, the location thing was an issue because we are scattered. How do you keep up with each repair shop without the proper meeting structure? So this was the starting point at that time at 21. We had that one production meeting available. And of course, we were then hit by COVID, which actually then allowed us to connect quite differently with the repair shops using Teams. So we started these daily morning meetings with each repair shop through the Teams. And that way we already gained the follow-up meetings for daily purposes throughout the week. The agenda was daily issues, prioritization, changes in resources, and that way we could quite differently already react to any changes during the week. We quite then started to think that the daily meetings were really good because we got raised all the issues that there was in the production. But then we started to think that how do we perform in total? We didn't have understanding how often and which kind of problems we would actually face, and how large is the scale and the impact. So we started this workshop we together decided the method how we would start to track our production interference cases. And here you can see our first version of a daily management board, where we had categorized our main production interference items. Also, we implemented action point tracking with responsible persons. And also we started to bring visual the finished work trends also. So we have a system, ERP system in place, but we also discovered that the data from the system was not brought visible to the repair shops. When implementing the first whiteboard to the repair shops, we of course then had amended our production meeting structure with the weekly whiteboard meeting. So we gather around the whiteboard once a week, and we discuss about the issues that have been encountered. We were trending them, and also we decided on the action points and kept tracking of those actions at that meeting. The next stage where we started to think was that, okay, we are quite nicely now tracking our way backwards, but how do we anticipate what's coming ahead? And we started to implement like these features to the board where we can actually see our forecast. So we built these reports to support our whiteboard meetings. And here you can, for instance, see an example of a report where we have the current stock situation and from the planning side, our demand. So this was also then part of our weekly meeting structure to first talk about what has happened in the past and then what we are facing in the future, and if there were any issues or something like that already identified in an early phase. In 23, we still continued to develop the daily weekly board. We amended the board with transparency to skills, also implemented 5S and safety view, and then a bit adjusted the production interface view to this kind of impact matrix to understand also the magnitude of the interference of that specific topic. So the skill side is showing a matrix where we identified the skills for different operators. So in that sense, it gives to the management a view where we have gaps in skills, but also for the operators, they can see where are there still room for learning new things and getting to be a multi-talented worker. For the impact matrix, this was brought also so that the board would be compact and hold all the elements. But with the matrix, we were able to identify the topics that actually have a significant impact on the work, so that it might be even interrupted, or if we have cases where it's slowing down and it can be solved, but we might want to track those cases, and if those are like continuously coming up, we should probably do some kind of exercise to eliminate those causes altogether. Our visual methods are something that we have also developed here. So, for instance, for this production interference matrix, we still have the categories, but now instead of like a steady table, we use different color of magnets to identify different categories for the interference. This year, we have still developed the whiteboard, so we have like focused more on the weekly targets. So depending on the repair shop, we actually already have targets for the weekly level, and we keep track on how we perform there. But also this year we have been focusing on also sustaining our major pain points, which we have also discovered. You might quite nicely understand that this lean development is not something that happens overnight. So you can see here that we have had some major issues also sustaining our 6S. So that has been our main theme for this year, to also make sure that all the work is not gone to waste. We see that there is really concrete benefits for the daily management. Here is some key metrics that we follow here at the repair shops. And I think the most significant gain here is the decrease on our turnaround time for the average of our repairs. So the turnaround time is calculated from when the component is arriving to the repair shop to the point when the work is finished. So we have had a significant decrease there, which we think that really makes us a really competitive partner in the market. Also, we have increased our quantity of finished repairs at the same time, and kept our productive man hours in a decent level, which really has given us a really good productivity index. So this was from my side, from the daily management, and I'm now giving the turn to Ronnie to tell you about our pull project in one of our repair shops.
Thank you, Jonna. So we will discover more about the battery maintenance this time. We started on value stream mapping workshops on the battery shop. We want to learn about the process in together. It was something that we have been doing for quite a lot of time, but we haven't like dig into it so much. So we wanted to learn about the process. We also wanted to know that is the capacity right at the moment, and do we have like the right amount of spare batteries in our process. Same time, we wanted to remove and identify some waste, and also introduce different kind of continuous improvement tools to the team that are actually working on the site, so that we really want to empathize their ideas and give them a chance to affect really well to their daily jobs. You can see a video scrolling down there. It's a simplified view of the process where the battery is multiple times discharged and charged again, and then there are some tests, and then liquid levels are fulfilled and these kind of things, but we don't have this time to dig into details from there. But what we understood from the current state value stream map was that there is quite a significant differences on the process step lengths. There are from 5 minutes to 16 hours, and some of the value adding steps are actually also long, because as everyone knows, when you're charging your phone or your laptop or whatever, it takes a lot of time. But when we're talking about aircraft batteries, they are quite big and they take quite significant amount of time. So there were almost 16 hours of value-adding steps as well. But these long taking process steps were clear pace markers for our process. We counted the takt time for the battery shop based on the demand from our line maintenance. So we are providing batteries to the line maintenance that are actually changing the battery to the aircraft. We also noticed with the information from our mechanics that around 30% of our batteries will fail during the capacity test of the overhaul process of the battery. And that's quite significant amount of batteries, because this always means that we will need to recharge them and do the test again. So, and that's a quite long taking step in the process. So we needed to do a deeper analysis on that. We identified the loops. Certain things are done with the first in, first out method, but then the pacemakers are always stepping in and distribute or disturbing the flow of the process. What we had as a worst case scenario for the current state of focus was that one aircraft would lose all its batteries during a long weekend. So the battery shop is working from Monday to Friday with office hours. So in case one aircraft would lose all its batteries during a weekend with a bank holiday added to that, plus the regular consumption, so that would be the worst case scenario or the highest demand for us. And based on that, we were calculating the future state. So we needed to define the service level based on the worst case scenario. Those also affected to the supermarket sizes from our processes. So we needed to define the correct level of spare batteries for each battery type and define a correct buffer for our ready battery components. We gave the supermarkets simple names from A to B to C and D, so we can understand that in which stage with which battery is actually at the moment. Here you can see the future state map. The D stock is the done one, where all the batteries are visible for our line maintenance and they are ready to be used. And here you can see typical Kanban pull system. Then we want to simulate this system without interfering our production. So, one step back. So here, so we used 2 sheets of A3 paper and we draw a layout of the repair shop on it, and then we used Lego bricks to show these batteries how they are moving on the battery repair shop. Each Lego brick is representing different type of battery, and there is actually the exact amount of batteries that we had as spare parts at that moment when we simulated this system. So what did we learn from the game? We used the forecasted consumption in the first round of game, and we kind of think that this is a bit too good to be true. And then we noticed that we weren't incorporating the failed capacity test as a part of this test. And then we placed a second test also, where we used historic consumption from our ERP system, and we also added the failed capacity tests to there. The historic consumption also included few demand spikes as well. And with the pull system, we were able to respond and the customer was satisfied, and we noticed that this system works and we can go live with the plan. So this way we were able to test the pull production system without affecting our normal production. And also this game could be used to train our personnel as well. Now, for the end, few visualizations that we came up and all together with the mechanics at the repair shop. So to visualize the battery stock level in the stock D, as mentioned, the one that is showing to line maintenance is used with a magnetic board with magnets on it. Again, each color representing each aircraft battery type. The first thing the mechanics do when they enter the shop in the morning, they will check how many batteries have been consumed, and they will adjust this magnetic board to correspond that situation. This way, they can prioritize their work, and it's easy to them to see what battery type should be prioritized in the first place. Then we introduced the supermarkets, the minimum and the maximum sizes per different battery type. And also you can see these different colored wires, and these are used to short circuit the battery. And actually the mechanics used these already before the development, and it's easily visualizing the status of the battery, that what is the next step for it to be done. Then the actual charger of the batteries, it's controlled by computer, and we can simultaneously even charge or discharge or perform capacity test for 4 different batteries per side. And we have 2 of these chargers. They are against each other, and there's 2 screens, and one of them is showing the status of 4, and with different colored magnets as here as well, we can show easily that what status of the charging or capacity test or discharging is ongoing in the process. Here are the pictures from the shop, just a really simple magnet board, and then the magnets also used for the charging, or the screen for the chargers here. Here is also the work order for our battery. So we started to mark to that work order that which side of the charger the first discharging of the battery had done, because this basic information of the battery would need to be always typed in manually to the charger, and it can remember what batteries has been used there previously. So by marking to the work order that which side of the charger has been used, we can easily avoid to manually write again all the information again. So really simple marking of A or B side. Then about the capacity test, we used a regular marker to mark the batteries, that how many times it has taken to pass the capacity test. You can see later on a decision tree which helps the mechanics to choose different battery to use for the next, so that we don't waste time on creating a lot of those capacity tests. And also we can change the cells of the battery. The battery is full, around 20 cells in each of them. And if we need to replace one, then we will create some markings on the head of the cell that we can easily see when we remove the cover of the battery. So it's easily visible for the mechanic. And why we will need to know about that? Well, because there's a limitation by the manufacturer of the battery that if we change more than 5 of the cells, it means that we will have to replace all of the cells, or the battery is basically scrapped and we cannot use it anymore. So this way we can easily see how many cells have been replaced for this certain unit. And here is again pictures from the workshop. Here's the charger, and you can see the A and the B side, and on each of the ends there is a charger which can control 4 batteries at the same time. Then there's the picture of a head of the cell, and I hope you can see it now, but it's a bit dark. But there is on the upper one there are markings of the cell head, and what indicates that this cell has been replaced previously. And then the markings on the actual battery. This indicates how many capacity tests it has been taken on the last visit to the shop, so we can prioritize the batteries if we are in a hurry. And here is the capacity test procedure and decision tree that has been made to help the mechanics. If the battery comes without any markings, then it's okay to try 3 times to do the capacity test. On the other hand, if the battery is already marked with 3 different markings or dots on the battery, then we will just give it one try, and if it fails, then we would start to repair the cells or then scrap the whole battery. And this way we can easily adjust the amount of spare batteries. So the main result for this was that we were able to now replenish the stock in 1 day compared to previous 3 to 4 days, and we have simple visual production control elements in the workshop. And next step is to have a similar approach in our aircraft wheels and tires production as well. Thank you. This was, I think, everything we have at this point. Do you have any questions? Maybe Juha can have us.
Thank you, Jonna and Ronnie. Thank you very much. At this point, there are no questions yet, so I take the opportunity to ask Jonna about the turnaround time at the repair shop. You had it in the beginning 33 days and now 17 days. What is the next target? Could you reveal something about that?
Well, our target for this year was actually 22.5, so we have outdone ourselves in that respect. And we are in a good level with the average turnaround time. We have actually been now focusing on our working in progress, so that we implement more first in, first out methods in the repair shops, and try to really focus on lowering the turnaround time through that still. So maybe relating to component maintenance services, in the market, 14 days is quite normal turnaround time that might be promised to customers. So that is maybe something that we will target next.
All right, good. Thank you. Ronnie, you mentioned the future plans. Do you have anything, any achievements on the tire and wheel area already, which you can tell us, or work in progress?
Sure, it's still work in progress. We have started the current state value stream mapping at the point. We've done some clockings and have discussions with the team members, and we already have good ideas from the mechanics, and I really appreciate that they are having this good insight that they have from their job, and everyone seems to notice that this is a good thing, and they are enjoying it. So it's nice to work with them and see some progression on there as well.
All right, very good. Maybe a question to you both. How do you see lean thinking spreading across Finnair as a whole company?
We are surely working on that. So we have been planning different types of really hands-on training for our workers in order for them to learn more practical lean thinking, root cause analysis, and also 5S is really strongly present, also enhancing that understanding why we do that.
All right.
Yeah, and maybe one addition to that is also that we have now started our own lean program where we are teaching primarily technical operations personnel, but we already have few candidates from the groups as well. So it's really nice to see that there are interest in our company wide.
Very good. Thank you very much for your presentation and answers. We have to stop now. Have a good day.
Thank
Good
you.
day.